Hello friends and welcome to the new session of Maths Made Easy. So in this particular session of straight lines, we will discuss some typical problems which are related to the straight lines and also try to understand some basic concepts of straight lines. Friends, it's my request to all of you to please don't miss any part of this video and watch the complete video till the end because it contains the problem which are related to the basic concepts of straight lines, and this will clarify most of the problems related to the straight lines. So if you like my video, please subscribe and press the bell icon so that you can get the latest upcoming videos. Also don't forget to share my videos. So friends, we will start with a typical problem of straight lines as you can see in your screen, and that is we have to find the gradient and the y-intercept of the given equation or the given lines. So here we have two equations and we will solve both one by one. So here we take the first straight line equation, and that is 3x plus 4y equal to 12. Now friends, as we already know, the straight line is shown by the given equation, and that is y equal to mx plus c, and where m is the gradient and c is the y-intercept of the given line. So the first thing we have to do is we have to bring this equation of the given problem in the standard straight line equation. And on solving, we get this equation y equal to minus 3x plus 3. Now we can clearly compare both the equations. So the gradient m will be minus 3 by 4 as you can see here, and the y-intercept c will be equal to 3 as you can see from this equation. Now we come to the problem b, and that is y minus 3 equal to 2x plus 4. So in the similar fashion what we have done in the earlier problem, we have to bring this particular equation in the standard format. So on further solving, we get this particular standard format of straight line. Now we can compare directly this equation in the standard format. So as you can see here, the gradient m will be 2 and y-intercept will be equal to 11 from the given equation. Now friends, we come to the next typical problems on straight lines. Now here we have to find the length of a line segments between two coordinates and also to find the equation of a line which is passing through the given coordinates. So our problem is, as you can see here, find the length of a segment of a line with coordinates 2, 4 and 16. Also find the equation of the line passing through the given coordinates. So friends, as we know, the length of a line segment is given by the formula under root of x1 minus x2 whole square plus y1 minus y2 whole square, wherein x1, x2 and y1, y2 are the two coordinates of the given line. So for the given problem, we can assume x1, y1 as the coordinate 2, 4 and x2, y2 is equal to 16 as per this problem. So on placing the value of x1, y1 and x2, y2 in this particular equation, we can get the value of the length of the line segment. So we get the value of under root 52. Now we come to the next part, and that is we have to find the equation of the line which is passing through the coordinates. So for that we know we have a gradient point form equation of straight lines, and that is y minus b equal to mx minus a. So first we have to find the value of m. So as we know, the value of m can be derived out from this particular equation. So we have placed the value of x1, y1 and x2, y2 in this particular equation, and we get the value of m. We can place the value of m and ab. Now we have considered ab as any one of the coordinates through which line is passing. So we have considered 2, 4 as the value of a and b. You can also consider the value of ab as 16. The answer will remain same for any of the coordinates. Now as you can see here, I have placed the value of ab and m in this particular equation, and we get the final equation as this one, y equal to 3 by 2x minus 11 by 2. Now friends, we come to the third typical problem of straight lines. So the problem is we have to find the equation of a line which is parallel to x minus 2y equal to 4 and which is passing through the coordinate minus 4 and 2. Now friends, our equation is x minus 2y equal to 4. So as we know, the standard form of our straight line equation is y equal to mx plus c. So in order to get the value of m, we have to bring this particular equation in the standard format. So on further solving this equation, we get 2y equal to x minus 4, and on further solving we get y equal to 1 by 2x minus 2. Now if we compare this equation with the standard format equation, we get the value of m. So the value of m for this particular line will be 1 by 2. Now friends, we will try to explain this particular problem with the help of graphs. So the equation x minus 2y equal to 4 can be shown by the blue line, as you can see here. And let us assume the line which is passing through minus 4 and 2 is the red line, for which we have to find the equation. Red line and the blue line are parallel to each other. So already we know if the lines are parallel to each other, the value of m or the gradient or the slope of a line are equal. So as we know, the gradient point form of a straight line is given by y minus b equal to mx minus a. So the value of a and b through which line is passing is already given in the problem, and that is minus 4 and 2. Now we have got all the unknown variables. So here you can see I have already placed the value of m, a and b here and solved this particular equation. And finally we got the equation of straight line, that is y equal to 1 by 2 x plus 2. So we can see this line is parallel to the equation which is given in the problem and which is passing through the point minus 4 and 2. Now friends, let us see one more typical problem related to straight lines. So in this problem, we will try to understand how to find the midpoint of a line and how to find the equation of a perpendicular line. So our problem is, as you can see here, find the problem of a perpendicular bisector of a line segment PQ, where the coordinates of P are 3, 1 and the coordinates of Q are 7, minus 4. Now friends, we will try to understand this particular problem with the help of graphs to make it more easy for understanding. Now as per the problem, we have a line segment PQ which coordinates are 3, 1 and 7, minus 4. And we have to find the equation of a line which is perpendicular to this line. So let that line be AB, which is passing perpendicular to PQ. Now, in order to find the equation of any line, we need two basic things. One is the gradient of a line, and the other is any point through which it is passing. So, in order to find the gradient of line AB, first we will find the gradient of line PQ. Now, as you can see here, I find the value of gradient M1 for line PQ, and that is y2 minus y1 upon x2 minus x1. So we have placed the value of coordinates P and Q here, and we get the value of gradient of line PQ, that is minus 5 by 4. Now let us assume the gradient of line AB be M2. So as we already know, if the lines are perpendicular to each other, the product of their gradient is always equal to minus 1. So since PQ and AB are perpendicular to each other, the product of the gradient of these particular lines will be equal to minus 1. So if we place the value of M1, we can get the value of M2. So as you can see here, I place the value of M1 which we have already derived from here. So we get the value of M2 is equal to 4 by 5. Now we will get the coordinates of this particular point, which is the midpoint of PQ. Now we will find the coordinates of this midpoint of the line PQ through which line AB is passing. So let the midpoint be M with the coordinates A and B. From here you can see I have derived out the value of point AB by placing the value of x1, x2 and y1 by 2. We get the value of AB as 5 and minus 3 by 2. Now as you can see in the yellow highlight portion, we have got the slope of the line M2 and we have got the coordinate of the line through which it is passing. So friend, as we know, the gradient point form of straight line equation is y minus b is equal to mx minus a. So we have placed the value of b, m and a in this particular equation. So on further solving the equation, we get final equation of the straight line